Good morning, my pre-calculus class. I hope you guys are having a great day. I hope you guys did a fantastic job on that Chapter 7 test, which I'm quite sure you all did amazing. So we're getting ready to start Chapter 8, and Chapter 8 is going to be a lot of information on applications of your trigonometric functions. So we're going to first start off with Lesson 8.1, which is right triangle trigonometry and applications. This would be starting out with stuff that you have seen previously before. This should not be anything new for the first half. The second half will definitely have a little bit of new stuff in this lesson today. Alright, so for today's lesson you're going to need paper, you're going to need pencil, your trig identities. That's going to have your things like your reciprocal identities, your quotient identities, the Pythagorean identities. You're going to need those things with this lesson today. A scientific calculator, because you're going to need to be able to use your sine, cosine, and tangent functions, and then you're also going to need homework 58 access to this at the end of the lesson. Now again, remember you can find this scientific calculator online at calculator.net. This will also give you that free scientific calculator, which you can use there as well unless you have one. A lot of you have your own already, which is amazing. Alright, so we're going to go ahead and get started. So I'm going to go ahead and change this paper out real fast and switch us over to the first thing that we're going to talk about today, and that is our trig ratios, which the majority of you already know these trig ratios, so this is nothing new, but a few of you, maybe it's kind of sat on the back burner, and we're going to bring it to the front burner and put it on high heat for you to learn. Alright, so the first thing we're going to talk about is our trig ratios. So let's write this down. If you don't have these, or you don't remember them, take a moment and make sure you get these. If you have to even pause the video after you write them down so that you have time to copy everything in and have that, because you're going to want to put this in your notes somewhere, your trigonometry ratios. Alright, there are 6 trig ratios. They're going to use these from ones we learned in geometry. For those of you that had geometry, I know I taught all this beautiful information to you, so let's see how much was in your brain. Alright, so our first one is going to be the sine ratio. So our sine ratio is going to be, they'll say theta, and theta will represent any kind of angle that we have, no matter what degree we have. So that's theta. This is equal to the opposite leg over the hypotenuse. So it's kind of like your abbreviation SO. S-O-H. So. O for opposite, H for hypotenuse. So sine of your angle equals opposite leg over hypotenuse. Alright. Our next one will be the cosine. So the cosine of theta will be equal to the adjacent leg over the hypotenuse. So this is ka. So ka. And our third one that we're going to talk about is your tangent ratio. Alright, so we go ahead and get that tan. Alright. And that will be our opposite leg over adjacent leg. Toa. So it's like a little chant. Soka toa, soka toa. So make sure you get that little soka toa going, kind of get your own little rhyme or dance to it. Alright, these are the first 3 original functions that we have. We have sine, cosine, tangent. Alright, so now we're going to give you the ratios to their reciprocals. So I'm going to move this paper up. Alright, so I'm going to go back to the sine. So the reciprocal of your sine is your cosecant. So C-S-C, cosecant of theta. Since it's a reciprocal of the sine, it'll be a reciprocal of the ratio. So it'll be the hypotenuse over opposite leg. So this means my cosecant is hypotenuse over opposite. All right, we're going to move to the next one, which is your secant. That is the reciprocal of the cosine. So that would be the hypotenuse over the adjacent leg. So therefore your secant of theta is equal to h over a. Ha! Ho ha! And then we're going to move to the final one, which would be our cotan. It's going to be reciprocal of your tangent. So that would be your adjacent leg over your opposite leg. So the cotan is A over O. So you can make a little ho ha ayo. Make your little song there, little rhyme. So you got soka toa ho ha ayo, soka toa ho ha ayo. Look at that. See, we gave you a little rhymey there going on. You know, you guys like it. All right. So we're going to go ahead and start working with these a little bit in solving some problems or examples how we're going to use ratios to solve everything we need. So what I'm going to do is move this out of the way for a second, bring it back down. I'm going to clear this page, and I'm going to make our little ratios here at the top. Our so ka toa, and then we'll put the reciprocals below them. The ho ha then our ao. All right, so now we've got the sine and its reciprocal, cosine and its reciprocal, tangent and its reciprocal. All right, so what we're going to do is start off by trying some problems where they're going to give you a diagram. And then from this diagram, you're going to have to use your Pythagorean theorem. So we want to make sure we add this in here. You're going to need to know the Pythagorean theorem. And we're going to help you out a little bit of ways on this to help manipulate it to help you solve this problem better. So Pythagorean theorem, which we know is a squared plus b squared equals c squared. That's our Pythagorean theorem, which everyone knows. All right, so now we're going to teach you a few things of how we can set this up if you're trying to find a leg or hypotenuse. We're going to work through those a little bit, and I think that will help you guys out. All right, so we're going to go ahead and flip in your book. If you don't have a book with you, duh. All right, I'm going to go ahead and just draw you a couple of diagrams and pictures, and you might want to take a moment to write those down. So we're going to draw a right triangle. Right. Put our little right angle in there. There's our right triangle. Theta, this would be the angle that we will be dealing with. And then in this angle, we're going to label the sides. 5 and 12. All right, so now what I'm going to do is teach you how to determine what is the opposite leg, what is the adjacent leg, and what is the hypotenuse. So we're going to refresh your brain on all of that information. All right, so our hypotenuse will be the first thing that will be the easiest for you to identify because your hypotenuse is always directly across from the right angle. So this is my hypotenuse. And we're going to use the hypotenuse. It's going to be always represented by the C value. That is our C value. All right? So when we want to find opposite leg or adjacent leg, it all depends upon where your theta is located. Because opposite of theta will be the opposite leg, and sitting right next to or adjacent to your theta will be your adjacent leg. So here is my theta. If I go directly across from my theta, I find the 5. This is my opposite leg. And we're going to use A to represent opposite leg. Then we have the leg that lays right next to, or theta sits on top of. Theta sits right here on top of this line. That's where theta sits. That is my adjacent leg. The side that theta just sits down on, that is your adjacent leg. And we're going to let B represent the value of our adjacent leg. So what they're going to do is they're going to give you a picture like this. And they're going to ask us to find all 6 trigonometric ratios. The sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. But to do that, you have to know all values. We have to know the A value, the B value, and the C value, so we can know opposite leg, adjacent leg, and hypotenuse. Well, currently we know 2 out of the 3. We do not know the hypotenuse. So since we do not know the hypotenuse, we have to use our Pythagorean theorem right here to find the value of our missing side. All right, so we're going to use a Pythagorean theorem, which says a squared plus b squared is equal to c squared. All right, so A is our opposite leg, and that value is 5. So we're going to use our parentheses to substitute in, so 5 squared. All right, plus B, and B is our adjacent leg, and that value is 12. Then squared. And we're trying to find C, because we do not know it, making it C squared. So 5 times 5 is, well, 25. And 12 times 12 is 144. And this equals our C squared. Then we've got to add, so we'll get 169 is equal to C squared. I don't need to know C squared, I need to know C. So the opposite of squaring, or the reciprocal of squaring, is square rooting. So it means I got to find the square root of 169, and I got to find the square root of C squared. Well, the square root of C squared is C, and the square root of 169 is 13. Now we know that my C value up here, put up here, is now equal to 13. All right, so I'll put that in there. So now I have my A value is 5, my B value is 12, and my C value is 13. So I'm going to go ahead and bring this up a little bit, just a smidge, and write that value in there. My A value is equal to 5, my B value is equal to 12, and my C value is equal to 13. So if I keep knowing that, leave A always opposite leg, B always adjacent leg, and C always hypotenuse, it will help me with these ratios a lot more. All right, so that means up here we can say that this would be the same thing as the A value over the C value. And this would be the reciprocal, so this would be the same thing as the C value over the A value. And this would be the same thing as the B value over the C value. And the same thing as the C value over the B value. And over here, the opposite leg is your A value, the adjacent leg is your B value. So A over B, and we'll flip this guy to the same as B over A. So now if we use all that information, it'd be easy for us to find all 6 trig ratios, because now all we have to do is put them in the right order and simplify them as a simplified fraction. They will not be decimal values, okay? No decimals here. All right, so we're going to start with our sine of theta. So sine of theta is A over C. Well, A is 5 over C, which is 13. And 5 over 13 does not reduce any lower. That is as far as we can go. We'll now do our cosine of theta. Is the B value over the C value. So B value is 12 over the C value, which is 13. Then we will do our tangent. So I'll move this up a smidge and we'll come back down. Our tangent of theta is our A value over our B value. So to go here, put our A value, which is 5, over our B value, which is 12. Now we go to find the reciprocals. So we go find the cosecant of theta. We take our sign fraction and we just reciprocal it. So 13 over 5. And to find our secant of theta, we just find the reciprocal of the cosine. So 13 over 12. And then to find the cotangent of theta, we would just find the reciprocal, which would be 12 over 5. All right, so this is a pretty easy one because we were dealing with whole numbers and numbers that did not reduce. So now we're going to up it up a little bit and try something where we might see points where you would have to reduce the fractions. So let's go ahead. I'm going to move this and you'll keep into place these. Keep these off to the side so you can refer back to these, okay? All right, so here we go. We're going to give you another little picture. And this time our picture is going to be like this. All right, and we're going to have theta up here. And we're going to have this being 2. We're going to have this being 4. All right, so again, it's going to be important for us to identify our different components of what we have so we know what we're dealing with. So I told you the first thing that's easy to identify is to find your right angle and go directly across, and there you will locate your hypotenuse. Which is our C value. So our C value is equal to 4. So we know our C value. I told you that once you understand where your theta is located, you go directly across from theta, and this is your opposite leg. In our case, this is the A value because we said the opposite leg will be the A value. Then to find the adjacent leg, that is the side that theta sits on. So theta is sitting right there. It's sandwiched in between. And this is our adjacent leg. And that is our B value. So currently we know our C value and we know our B value, but we do not know our A value. So we're going to have to use our Pythagorean theorem to find that A value. So we're going to do A squared plus B squared equals C squared. So since we do not know our A value, we're just going to keep it A squared. Plus our B value, which is 2 squared. And then we'll take our C value, which is 4, and then squared. So we're going to go ahead and solve the values that we can. So we're going to leave A squared, A squared. All right, 2 squared is equal to 4, and 4 squared is equal to 16. All right, since we're solving for A, we need to get the A squared first, all by itself. So we need to move this plus 4 to the right side. So the opposite of plus 4 is minus 4. So we have to minus 4 on each side to make this equal. Otherwise, our scales are off. This cross cancels out, leaving me with just A squared. 16, take away 4 is 12. All right, so the opposite of squaring is square rooting. So we take the square root of A squared and the square root of 12. All right, we know the square root of A squared is A. But we've got to take the square root of 12 and break it down because we can't leave it as a radical if it breaks down. So you're looking for your factors of 12. So I'm going to come over here and make some factors of 12. To get 12, you can multiply 1 times 12. You can multiply 2 times 6. And you can multiply 3 times 4. So 1 times 12 will not help us out because 12 is not a perfect square. And if I divide it by 1, I'm back to where I started from. So this is no use to me. So the 1 factors are not. So now looking at your 4 remaining factors, 2, 6, 3, and 4, or 2, 3, 4, and 6. Which of these numbers are perfect squares? Okay, that's right, Miss Abby. 4 is a perfect square. So I'm going to circle 4. It's a perfect square. Now, are any of these other numbers perfect squares? Correct, they're not. So since none of the remaining numbers are perfect squares, we only have one option, and that is this multiple of 3 times 4. All right, so that tells me that A is equal to the square root of 4 times the square root of 3 because 4 times 3 makes 12. This is one way to do this. I will also show you a second method here in just a quick second, and then you decide which method you really like best. Move this up a little bit. All right, well, I know that the square root of 4 is equal to 2, and I can't do anything with that because 3 is a prime number, so it stays just like it is. So it means my A value down here will be equal to 2 square roots of 3. That is my A value. All right, so they told you I'd teach you another method, and again, you decide which one you want. You can list the factors, find the largest prime number, and then use the largest perfect square, and then its factor with it in order to break it down. And we'll do several of these throughout the lesson. All right, so now the other method is the division by primes. So you start out with your 12. Since it is an even number, it's divisible by is 2. That's the first prime number. 12 divided by 2 is 6. 6 is not prime, but 6 is an even number. It's also divisible by that prime number 2. 6 divided by 2 is 3. 3 is a prime number, so we stop. You take out one pair of 2's, so this represents one pair of 2's, and then your leftover piece, the square root of 3. So then how we can double check is if I square this 2, 2 times 2 is 4, times 3 is 12, and that puts me back to where I started with this 12. All right, so this would also result in one pair of 2's, and the leftover piece, square root of 3, put it back in the fridge. All right, so now we have our information. We know who our A, B, and C are, so we're going to go ahead and list those. A is equal to 2 square roots of 3. B is 2, and C is 4. So now we know who A, B, and C are. So from here, we now got to find all 6 trig ratios. All right, so we're going to first start out by trying to find the sine of theta. And from our page before of notes that we had, that you wrote down, the sine ratio is the A value over the C value. So our A value is 2 square roots of 3 over our C value, which is 4. When reducing things that contain radicals, you can reduce the things on the outside or the coefficient to the radical to the constant. These guys reduce. Just like in a variable. If you were to have, say, 2x over 4, this would be reducing to 1/2 x or 1/2 x or x over 2. And that's going to hold true the same concept here. We're going to treat this like an individual variable. It's a separate unit unto itself. So we're going to go ahead and reduce. And we're going to do 2 divided by 2 is 1. And 4 divided by 2 is 2. So we come across here, we got 1 times the square root of 3, which is just the square root of 3. And then we have it over 2. So that would be our sine of theta. All right, so now we're going to go ahead and move to the cosine of theta. I'm going to bring the screen back up. Because right now all we don't need our picture anymore, we just need our A, B's, and C's and the ratios from the other page. All right, so the cosine of theta is the B value, which is 2, over the C value, which is 4. And then we can reduce 2 fourths. We know 2 divides into 2 once, and 2 goes into 4 twice. So then our cosine ratio would be 1/2. Then we're going to do our tangent ratio. So the tangent of theta is the a value, which is 2 square roots of 3, over the b value, which is 2. So we could reduce 2 divided by 2 is 1, and 2 divided by 2 is 1. So on the top, we got 1 times the square root of 3, which is just the square root of 3, over 1, which is the same thing as the square root of 3. So now we have found the sine, cosine, and tangent. So I go down a little bit further and move this up because, again, we're going to be flipping things. We're going to do the cosecant of theta, which is the reciprocal or of the sine value. So it'd be our c value, which is 4, over our a value, which is 2 square roots of 3. So I'm going to go ahead and reduce this to start with. I know 2 goes into 2 once, and 2 goes into 4 twice. So on the top, I've got a 2. On the bottom, 1 times the square root of 3 is the square root of 3. All right, so we've learned in previous lessons and chapters that we cannot leave a radical in the bottom. So to rationalize this denominator, we have to multiply the top and the bottom by the given radical, square root of 3. So when we do that on the top, we get 2 times the square root of 3, which is 2 square roots of 3. When you multiply the bottom, square root of 3 times the square root of 3 is the square root of 9. Now, the square root of 9 is a perfect square, and that's the reason why we do that. So now we've got 2 square roots of 3 on the top, and the square root of 9 is equal to 3. Since 2/3 does not reduce, these cannot reduce, we just leave this as our final answer, 2 square roots of 3 over 3. These 3's cannot reduce. This is under a radical, this is not. All right, so now we're going to move to the secant. Okay, the secant of theta is the c value, which is 4, over the b value, which is 2. All right, so 4 is divisible by 2. But if you don't know that, you can do 4 divided by 2 is 2, 2 divided by 2 is 1, and then you can reduce 2 divided by 1 is 2. Then we're going to do our cotangent of theta is going to be the b value, which is 2, over the a value, which is 2 square roots of 3. So we're going to go ahead and reduce. 2 divided by 2 is 1. 2 divided by 2 is 1. So as we move over, we got 1 on the top, and 1 times the square root of 3 is the square root of 3. Again, to rationalize our denominator, we multiply top and bottom by the given radical, square root of 3. So now we've got 1 times the square root of 3, which is the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is a perfect square, which makes 3. Some of you will be able to go from here directly to here. You'll recognize that anytime I multiply a square root by itself, I just get what's under the radical. Some of you are really good at figuring that out. All right, we're going to do one more in this section. And then from here, we're going to move to the next section. So I'm going to go ahead, bring this back down. I'm going to clear this page out. We're going to start and do one more in this section. All right, so I'm going to give you another picture here. Let's give you another right triangle. We're going to go this way. It's a little bit shorter, a bit longer out. They're not always really tall and skinny. Sometimes they're a little long and fat. All right, so we're going to start this one out with being the square root of 5 over here. And we're going to put theta in here. And a 1 right here. So remember, the first thing we want to talk about is finding our hypotenuse. So to find our hypotenuse, we started our right angle. Bam, hypotenuse. Remember, hypotenuse is our c value. So now we know what our C value is. It is the square root of 5. Try to make that a little bit less ugly there. Hypotenuse. All right, to find our opposite leg, remember we start with theta and we go directly across and we will find our opposite leg. Remember, our opposite leg is represented by the value of A. To find our adjacent leg, the side where your theta sits on, that's your adjacent leg. And that is our B value, of this time of which we do not know. So to find the missing B value, we have to use our Pythagorean theorem. So we got to do A squared plus B squared equals C squared. So Pythagorean theorem, and then substitute in what we know. A is 1, so A is 1, and then squared. B we don't know, so B squared. And then our C value, which is the square root of 5, and that value is squared. All right, so here we go. We're going to square our 1. 1 times 1 is 1, plus B squared. The square root of 5 times the square root of 5 is the square root of 25, which is just equal to 5. So anytime we square a square root, we just get what's underneath the radical. We're solving for B squared, so we're going to subtract 1 from the left, and we'll subtract 1 from the right. So 1 minus 1 go away, leaving me with B squared. And 5 minus 1 is 4. The opposite of squaring is square rooting. So we find the square root of each side. Square root of B squared is B. The square root of 4 is 2. That's beautiful. Works out gorgeous, gorgeous. So now we're going to go ahead and put that B value in here. It's 2. And then we're going to go ahead and list our ABCs. ABCs, right triangles and me. Oh yeah, got to throw them out there. A is equal to 1. B is equal to 2. And C is equal to the square root of 5. All right, so now we know our ABCs. So from here, we're going to start finding our sine, cosine, and tangent. So our sine of theta is the A value over the C value. So A is 1. Your C value is the square root of 5. All right, so how do we get rid of this radical in the denominator? How do we rationalize it? That's right, Abby. We go ahead and we multiply the top and the bottom by the square root of 5. All right, Miss Jenna, if I multiply 1 times the square root of 5, what do I get? Correct, square root of 5. And if I multiply the square root of 5 times the square root of 5, Miss Jenna, what do I get? That's correct, 5. This fraction does not reduce to 1. You cannot divide what's underneath by something that is not underneath the radical. So in order for the reducing them, they either have to be on the outside or they both have to be underneath the radical. So this would be the final answer to the sine of theta. All right, we're going to do the cosine of theta, which is our B value, which is 2, over your C value, which is the square root of 5. All right, Alexa, how do I rationalize this fraction? Correct. I'm going to multiply the top by the square root of 5 and the bottom by the square root of 5. Okay, Alexa, when I multiply the top, what do I get? Correct. 2 square roots of 5. And when I multiply the bottoms? Correct. That is 5. Can I reduce that any lower? You are correct. I cannot. All right, move this up. All right. So now we're going to go find the tangent of theta, which is the A value, which is 1, over the B value, which is 2. So I cannot reduce 1/2. So those are my 3 first answers. These are the first 3 of the trig ratios. So now we're going to go find the reciprocals. All right. So with the reciprocals, you want to find which is the easier to reciprocate. If I reciprocal this one, let's go ahead and start with it. Let's just do those ratios. I think that might keep it simple and you won't make mistakes along the way. All right. So Elena, our ratio would be what for the cosecant? What over what? Okay, C over A. Beautiful. So what's my C value, Elena? Square root of 5. Okay. Over my A value? Correct. 1. And when I reduce that, Elena, what do I get? Correct, the square root of 5. All right, Jojo, what is the ratio for my secant of theta? Correct, C over B. All right, so what is my C value? Correct, square root of 5 over my B value. Correct, 2. Can I reduce that any lower? You're correct. This is the way it goes. All right, Miss Mackenzie, what would be my ratio for the cotangent of theta? That's correct, B over A. So what's my B value? That's right, 2. And my A value? That's right, 1. Can I reduce that any lower? Yes, ma'am. Good job. 2 divided by 1 is 2. So now we've found all 6. 1, 2, 3, 4, 5, and 6. When you're online, they're going to ask you for the sine, then they'll ask you for the cosine, and they'll check your answers along the way. So please make sure you're taking your time and working through that. All right, so now we're going to flip and go back to the second part of our lesson, which is going to be talking about complementary angle theorem. So I'm going to go ahead and move this out of the way. And we're going to talk about complementary angle theorem. So let's write that down. Complementary angle theorem. All right, on your complementary angle theorem, we're going to think about complementary angles back from geometry. So let's first make a note about that, what complementary angles do, because that's going to help you out. And if you don't remember from geometry, hopefully I'll bring this back into remembrance. So complementary angles are two angles whose sum equals 90. So now we got to figure out what we know what sum means. So two angles, that means two separate angles. Sum means two. That's right, add. So I'm going to take the two angles, I'm going to add them up, and they're going to equal 90 degrees. So let's think about some angles here. And then we're going to talk about what would be their complementary angles. So we're going to first start out with the sine. So I'm going to tell you the sine of any angle, theta, will be equal to the complementary angle of the cosine of that same angle. So for instance, we're going to give you an example of this so you can kind of see how this works. If we have, say, the sine of 30 degrees. So if my angle is 30 degrees, what can I add to 30 degrees to get to 90 degrees? Because remember, the two values have to add up to 90. So 30 plus what is 90? That's right, it's 60. So this would be equal to cosine of 60 degrees. So we find the sine of 30 is the same as the cosine of 60. All right? Okay. So now we're going to move to the next one, which would be the cosine of this. If I suppose I gave you the cosine of, let's say, 40 degrees. So what do you think the cosine of 40 degrees would be equal to? Correct, the sine of 50 degrees. So I'm going to go ahead and put this down here. So the cosine of a theta will be equal to the complementary angle of the sine of theta. All right? So I'm going to take the same thing here. I'm going to write it twice and give you some pointers on here. So I'm going to write this again. So the sine of 30 degrees is equal to the cosine of 60 degrees. I'll come over here and write this. The cosine of 40 degrees is equal to the sine of 50 degrees. All right, so in this process, the two angles, 30 and 60, are the complementary angles. So those are the complementary angles because 30 plus 60 makes 90. So in our picture here again, the 40 and the 50 are our complementary angles. Because 40 plus 50 makes 90. All right, so now the next part we want to talk about are called cofunctions. So sine and cosine are cofunctions. That means if I find the complementary to 30, it'd be the opposite of the sine would be the cosine of these cofunctions. So here again, cosine and sine, these are cofunctions. You'll see them as interchangeable. The cosine of 40 goes to the complementary angle and the sine of that, and vice versa. All right, so hopefully that helps with those. So we're going to move, staying in the same vein with sine, cosine right now. We're going to deal with their reciprocals. So I'll move this up a smidge. Woohoo! Sorry guys, that was a little cray-cray. All right, so we're going to do the cosecant and the secant. So the cosecant of theta will be equal to the complementary angle of the secant of theta. And we're going to throw that in here with the secant of theta will be equal to the complementary angle of the cosecant of theta. All right, so we're going to go ahead, just up a smidge, and we're going to put these in. We'll just do one instead of two separate ones because they'll mean the same thing. All right, so we're going to go ahead and list those. Let's put the cosecant of 70 degrees will equal the secant of 20 degrees. All right, so here what we want to notice in this picture is that our 70 degrees and our 20 degrees, those are your complementary angles. And then the cosecant and the secant are cofunctions. And they work the same way as the sine and cosine does. All right, so now we're going to move up into the final set here, which will be the tangent of theta equal to the complementary angle of the cotangent of theta, and the cotan of theta will be equal to the complementary angle of the tangent of theta. All right, so again, we'll just do one sample this time. So you guys can just have the one sample to follow. Let's do the tangent of 35 degrees will be equal to the cotangent of 55 degrees. All right, so we're going to make notes here. 35 and 55 are complementary angles. And your tangent and your cotangent our co-functions. All right, so we're going to use this here to solve some problems and teach you what this means. All right, so here we go. I must bring this back down, and then we're going to use some pictures, and we'll help you solve some problems here, which I think would be beautiful. I think you guys are going to get this real well. All right. Okay, so we're going to start with a sine of 38 degrees, and we're going to minus the cosine of 52 degrees. All right, so right now they're asking us to use this, and there's no calculator involved. You cannot use your calculator for this. And some of you I know when you're at home, and I'm not there, you'd be cheater pantsing. But if you are on an SAT or an ACT, they're not allowing you a calculator section, or if you're at college and you're taking a class and they've got a little camera watching you, you won't want to know how to do this, man. So you better listen up. All right, so now, no cheater britches. Since we know that the sine of 38, we've talked about here, that the sine of 38 degrees should be equal to the cosine and then the complementary of 38, which would be 90 minus whatever 38 degrees happens to be. Now, some of you in your little noodle brains will be able to decide 90 minus 38 without any help. So this means that the sine of 38 degrees is the same thing as the cosine of 52 degrees, because 38 plus 52 is equal to 90. So I can rewrite this through substitution and say that's the same as the cosine of 52 degrees. And then if I minus the cosine of 52 degrees, so what's the cosine of 52 minus the cosine of 52? That's right, it's equal to 0. So anything minus itself is equal to 0. All right, let's try another better. All right, we're going to do the cosine of 10 degrees over the sine of 80 degrees. All right, so let's take a moment and do some processing. So we know the cosine of 10 degrees is equal to the sine of what? That is right, Alexa, 80 degrees, because 80 plus 10 is 90. These are complementary angles. So I'm going to go up here and do this, replace this with the sine of 80 degrees over the sine of 80 degrees. What's anything divided by itself, Miss K. Curry? That's right, 1. And that would be our answer. All right, we're going to move on. We're going to do another butter. All right, here we go. We're going to do 1 minus cosine squared 20 minus the cosine squared 70. So this is still, we could still change these out. So let's look at it this way. Let me bring it over here. If we have the cosine squared 20 would be equal to the sine squared, and then what's the complementary angle to 20? So 20 plus what is 90? That's correct. It is 70 degrees, Aiden. Fantastic job. So I'm going to go over here and I can replace my sine squared. So I'm going to go ahead and do that real quick. Replace my sine squared. So let's do that. 1 minus, and we're parentheses because I'm substituting the sine squared 70 minus the cosine squared 70. All right, so everybody got that down there? Yeah. All right, let's take it one step further. This is a Pythagorean identity. It's part of one. So if we use a Pythagorean identity, we can do another substitution again. So on your Pythagorean identities, we've got our 1 out here, minus and in parentheses. So on our Pythagorean identities, let me bring this up. I'm going to grab my Pythagorean identities so I can show you what I'm talking about. On our Pythagorean identities, we've got the sine squared of any angle is equal to 1 minus the cosine squared of that same angle. So these are those Pythagorean identities that you guys are going to need. The reciprocal, the quotient, and the Pythagorean. All right, so move this back. So this is equal to 1 minus the cosine squared of 70. Then we'll finish out minus the cosine squared 70. So some of them are asking you to pull back in. So remember there's like a 1 right here. So I got to distribute this negative 1 to this and the negative 1 to this. So when I do, I get 1, and then negative 1 times positive 1 is a negative 1. And negative times a negative is a positive, cosine squared 70. Then I got minus cosine squared 70. All right, so now we got 1 minus 1. Well, they cancel each other out. Then I got the cosine squared cosine squared 70 minus cosine squared 70. Well, let's cancel each other out. So this ends up equaling 0. Fantastic job here. All right, so now we're going to move on to, I think that might be the last one we do. I think that should be. Let me do one more. Let me do this one. I think you need to see this one because I think that would be important because we need to do some tangents in here too. I don't want to leave the tan out. All right, so let's do the tan one. All right, so we got the tangent of 20 degrees minus the cosine of 70 degrees over the cosine of 20 degrees. All right, so let's go back here and pull up this identity that we have. Remember, the tangent of theta is the same thing as the sine over the cosine. Well, currently we have cos over cos. So we need to change this cosine to the sine. And we know using these identities we just have now, the complementary angle ones, that the cosine of 70 is equal to the sine of 20. All right, so now I can go back and rewrite this, saying the tangent of 20 degrees minus the sine of 20 degrees over the cosine of 20 degrees. All right, when I know the sine of an angle over the cosine of an angle is equal to the tangent of an angle. So now I've got the tangent of 20 degrees minus the tangent of 20 because this angle is 20. So tangent of 20 degrees minus tangent of 20 degrees is 0. All right, so then we have one final one to go, and that is going to be our cosine and sine. All right, so here we go. All right, we're going to put cosine of 35 degrees times the sine of 55 degrees plus the sine of 35 degrees times the cosine of 55 degrees. All right, so if we took this cosine of 35, we know that the cosine of 35 degrees is equal to the of 55 degrees and vice versa. We know the sine of 55 degrees is equal to the cosine of 35 degrees. All right, so we're going to do a little flip-flopping here, and I think once you see this, I think it'll make sense. We're going to go ahead and take this cosine of 35 and write it as the sine of 55. So I've got the sine of 55 degrees times the sine of 55 degrees. And we're going to go ahead and change the sine of 35 to the cosine of 35. The cosine of 35 times the cosine of 35 degrees. All right, so now when we multiply something by itself, we end up squaring it. Remember, sine times sine is sine squared. So we do sine times sine is sine squared, and the angle they have in common is 55. All right, everybody good so far? All right, then over here, all right, then I got to fix my boo-boo. This should not be 35, this should be 55, because the sine of 35 is, bananas and squashes. The sine of 35 is the same thing as the cosine of 55, and that stayed 55 degrees. I don't know what I was thinking. Brain farting. Thank you guys for loving me through this. Cosine times the cosine is the cosine squared, and then my theta, which is 55. And you want these values to be the same, otherwise this no longer works. So remember, we got our Pythagorean identity that says the sine squared theta plus the cosine squared theta, as long as theta are the same value, is equal to 1. And thank you for being patient with me through that little boo-boo. All right, well, that is all we have for today. That is the lesson. So please make sure you take time to go through this, read it, watch it again, take notes, message me if you have any questions, and the homework is online tonight. Have a great and fantastical day. Bye.